Hello, everyone, and welcome back to your channel of Math and Engineering Made Easy. Uh, Today, we are going to solve some trig functions, trig equations. Uh, Usually, when you solve those, you have infinite solutions. What? Why? So if I'm solving for the value of theta, and you say, well, I solved it and I got 45. I'd say, but 45 is the same as a coterminal of 45 plus 2 or minus 2 pi, or plus or minus 30, 300, 360n, where n is any integer. So there are infinite numbers. So when I solve, I say plus or minus or plus 2n pi, where n is any integer number. But here they wanted to make it easy on you, so they said solve each equation for theta between 0 and 360. Or if we are given that in radian, they will say between 0 and pi over 2. Okay? So usually when you solve, you see that the sign is positive in first and second, cosine in first and fourth, tan in first and third. So always keep in mind that most of the time I will get two answers for a linear. If we call it linear, I meant linear meaning power of one. It's not linear, of course, but if first degree trig function, you should get two answers. And for a square, you get up to four, unless two of them are the same. So that's why I say up to four, didn't say four. So don't get an answer and say one value and say, oh, I'm done. No. In trig, you get two equations or two answers if you are between 0 and 360. Otherwise, you have infinite solutions. Okay, if there exists a solution. Because if I say, for example, sine theta equals 2, well, there is no such angle whose sine is 2. At least there is no real angle whose sine is 2. Okay? The sine is between -1 and 1. The cosine is between -1 and 1. So what are we going to do? I think we can either take I don't know, I'm going to take, say, the even numbers. The first equation said tan theta equals -3, and negative root 3. If you go back to the table that we did like 2 sessions ago, you see that if this was positive root 3, then theta would be 60 degrees. Tan 60 is root 3. The problem is it's negative. I know that the tan is here. All students take calculus. So it's first and third positive, second and fourth negative. So I have to have two values in the second and the fourth. Notice, we always measure the angle from the x-axis. Up or down, up or down. So if it's in the second or third and I calculate 60 degrees from here, meaning it's 180 minus 60, so theta equals 120 degrees. Very easy. If I'm in the fourth, this is 360 and I'm going to subtract 60, so 300 degrees. I really don't need calculators. I don't need anything if I know the values of that I have in the table. This one, I'm going to subtract 4 from both sides. So I get sine theta equals -1/2, because 4 is 8/2. 7 minus 8 over 2 is -1 over 2. I know that sine 30 is 1/2, but that's negative, meaning it's either in the third. Notice all sine. So the sign is positive up, it's negative down. So either the third or the fourth. If it's in the third, then it must be 180 plus 30. If it's in the fourth, it's 360 minus 30. Because sine 30 is 1/2. So just look at the absolute value, find the angle. We call it the reference angle, and then see if it's positive or negative. If it's positive and sine, we are here. If it's negative and sine, we are there. If it's positive and cosine, we are here. If it's negative and cosine, we are there. If it's tan and positive, we are here. If it's tan and negative, we are there. And again, sine and cosecant, cosine and secant, tan and cotan. Okay, next, I'm going to add 2 to both sides. See how easy they are? When it's the power is 1. So you get tan theta is 1, meaning 45 degrees, because at 45 degrees, the sine equals the cosine. So the tan is 1. The tan is positive here and there. So theta is 45 degrees if I'm in the first, or 180 plus 45 degrees, 225 degrees. Let's go to number 8. I'm going to divide by -2 both sides. Cosine theta is -√3/2. I know that if I didn't have the negative, this is the cosine of 30 degrees. 30 and negative, meaning I'm either second or third. This is, we said 30 degrees. So either 180 minus 30 or 180 plus 30. So theta equals 150 or 210. Isn't really very easy? Okay, I'm going to go to a different sheet and keep going with the negative, but here I have squares. That's why I picked this one. Okay. Alrighty, I'm going to divide by 2. I get cosine theta is -1/2. I know that the cosine of cosine 60 is 1/2. So I have 60 degrees, but it's negative. Negative for the cosine, meaning all or cosine. These are positive, these are negative. So again, we are either second or third. If I want to have 60 degrees, I either subtract 60 from 180 or add 60 to 180. So theta equals 120 degrees or 240 degrees. Again, we can use a calculator to check these, by the way. So if you want, you can do that. Add 3 to both sides. Equals 1. Cosine 0 is 1. Huh, 0. So if I am here, if the angle is 0, the cosine is positive, so I get theta equals 0. But theta also is 360 minus 0, which is 360. However, they told me theta is greater than or equal to 0, less than 360, not less than or equal. So the answer is just 0. Okay? There's no 360 because they said less than 360. Be careful. That's a trick. I told you there is up to 2 answers. In this case, there is only 1. Okay, tan square theta equals 3. Here, because it's a square, we can expect up to 4 answers. How 4? If I take the square root, I have to add plus or minus. So I get tan theta equals plus or minus √3. √3 for a tan, that's 60 degrees. But it could be positive or negative, meaning it can be either anywhere here, right? So it could be 60 or 180 minus 60, which is 120, or 180 plus 60, or 360 minus 60. I wish they want you also to enter these values in radians. I want you to get used to radians. So let's, even though they didn't ask for that, let's underneath those, write those in radians. Here they said 0 and 360, so they want it in degrees. Remember, to get radian, we divide by 180 and multiply by pi. Of course, if you this is 2 times 60 and 180 is 3 times 60. So it's 2/3, 2 pi over 3. 360 is 2 pi and 60 is pi over 3. So I have 2 pi, which is 6 pi over 3, minus pi over 3, that's 5 pi over 3. The difference, you can check. The difference between these two guys is 180, so the difference between these two should be 1 pi. 5 pi minus 2 pi is 3 pi, divided by 3, it's pi. Good. Okay, the difference between these two, by the way, is pi over 2. I already know that this is 5 pi over 6, right? And if I want to, uh, I'm sorry, 5 pi over 3. Why did I say over 6? Yeah, because I wanted to show you something. I said the difference is 90 degrees, meaning this is pi over 2 less. If I want to make that pi over 2, and this is 5 pi over 3, I have to take a common denominator of 6, right? 5 pi over 3 is 10 pi over 6, and I need to subtract pi over 2. But pi over 2 is 3 pi over 6, so you get 7 pi over 6. Or you say that 210 is 7 times 30, and 180 is 6 times 30. So when I divide them, I get 7 over 6. Okay, 45 is pi over 4. Difference is 180, meaning I add pi, so 5 pi over 4. 150. Notice that again. Forget about the 0, because you can say 15 over 18. 18 is 3 times 6. 15 is 3 times 5, so this is 5 pi over 6. 210, 21 over 18. 21 is 7 times 3. 18 is 6 times 3. So this is 7 pi. We already had it, 7 pi over 6. Here, I divide by 180. This is 2 times 60 over 3 times 62. It's 2 pi over 3. This is double that, so it's 4 pi over 3. And again, here it's 0, so it doesn't matter. 60 is pi over 3, times 2 is 2 pi over 3, times 2 is 4 pi over 3, times 5 is 5 pi over 3. We already did the 300 before. So it's not that bad. You can get those quickly, even if you are in radians. I'm going to divide by 2. So I get sine squared equals 1/2. I'm going to take the square root, not forgetting the plus or minus. So I get sine theta equals plus or minus 1 over root 2 or root 2 over 2. It's the same thing. I know that root 2 over 2 is 45 degrees. But now I can be in any one of these 4 quadrants because I have plus or minus, meaning everywhere. So theta equals 45 degrees, or 180 minus 45, or 180 plus 45, or 360 minus 45. You can do that quickly. This is pi over 4. This is 3 pi over 4. This is 5 pi over 4. And this is 7 pi over 4. Again, you can use the calculator, multiply by 180, and multiply by pi, meaning just divide these by 180 and add the pi. Last one. I'm going to add 1 to each side. So I'm glad it didn't take that long. We have cosine squared equals 1, so cosine theta equals plus or minus 1. I know that cosine 0 is 1. So theta equals, cosine, 0 or 180. But it could be also negative. Yeah, but cosine 0 is 1, cosine 180 is negative 1. And you said you said four answers. Yeah, they are 4. You know what? This is 0. And then this is in the first quadrant it's 0. In the second quadrant it's 180 minus 0. In the third is 180 plus 0, but these are the same thing. So you get 180, 180. And then 360 minus 0 is 360, which is 0. But Again, if it's, we don't write 360 because it's not part of the solution. If I want to write these in radians, I'm going to say 0 or pi. And that's it. So now if we completed this part of trig, and again, I know I'm boring, but if you want more information about trig, you can go and visit the trig, the the playlist of trig made easy, and you will find more examples and more equations if you like. Alrighty, so now we are coming to the end of the course. We only have one more lecture or session about graphing. Uh, since we are here, let me show you the graph of the regular sine, cosine, and tan, and even cosecant and secant and cotan quickly, since it didn't take as long as I thought it would. Okay, so I know that the sine is positive in the first quadrant and second, and then it's negative in the third and fourth. Maximum value is 1, minimum value is -1. So I'm going to say this is 1, this is 0, and that's -1. So the sine curve. I'm going to say this is pi over 2 or 90 degrees. We prefer to write it in radian, by the way. So pi over 2, pi, 3 pi over 2, and 2 pi. That's a whole cycle because after 2 pi, we return back to the 0. When you do the math, you will see that at 30 degrees is 1/2, and then 0.77, and then root 3 over 2.866, and then it reaches 1 here, but in a curved manner. It's not linear. And then it goes back to 0, and then down to -1, and then back to 0. So the equation or the graph looks something like that. Again, they won't charge you for not having the accurate values, but the general shape should be like that. It should start at 0 and end up in 0. The maximum is 1, the minimum is -1 at 90 and at 270, and it's 0 at 0, 180, and 360. Cos theta. Zero, pi over 2, pi, 3 pi over 2, and 2 pi. And then again, plus or minus 1. The cosine of 0 is 1. Then the cosine of pi over 2 is 0. Then the cosine of pi is -1. 3 pi over 2 is 0, and 2 pi, it goes back to 1. So it goes something like that. And then it starts to rotate in the, or to turn in the opposite direction until 3 pi over 2. And then it turns back in that direction. Finally, the tan. The 10, I think we have to do, okay, the 10 is a little, not tricky, but okay, let me get closer to this. Oh, there should be 4. Okay. You do it with a different color. So I will start here, and then here, and then here. That's weird. So I didn't. Okay. No, that's 5 again. Oh my God. Can't count. And these are 3. So okay, here is 0. Here is 90, not or pi over 2, and here is pi. And I will show you what's the problem here. Tan 0 is 0. Okay? Tan, and this is 90, okay? So this is 45 or pi over 4, and this is 3 pi over 4. The tan is a little tricky. Tan of 0 is 0, okay? Tan of pi over 4 is 1. Here is 1. But tan of 90 goes to infinity. So the 90 degrees is an asymptote of the graph. It looks something like that. It's turning in this direction. And then after 45, it starts turning in the opposite direction. If I want to continue here, I will go to negative pi over 4, and then pi, something that goes like down to negative infinity. When I am, oh my God, okay, guys, I should go to 90, and I will do it again on a different page quickly. Here is the tan. So let's say this is negative 90. So negative pi over 2, 1, 2, 3, 4. This is 0. And this is pi over 2 or 90. And this is 180 or pi. Okay. At 0, the tan is 0. At negative 90, that is an asymptote. And in fact, the 0 is an asymptote, and the 180 is an asymptote, and the 90 is an asymptote, and so on. No, I'm sorry, the 90 and the negative 90. So odd numbers or odd multiples of 90. At negative 90, I get negative infinity. At negative 45, I get negative 1. So this is negative 1. And the graph looks something like that. And then at 45, I have 1. So to the left of 90, it's positive infinity. To the right of 90 is negative infinity. So this goes down asymptotic here, passes through 1 and 0, and then here at 1. So this is negative 1, and this is 0, and this is 1, and then this is asymptote with the 270. This is the graph of the tan, and it keeps repeating every 180, not every 360 like the sine and the cosine. Now, if I want to plot the cosecant, which is the reciprocal of theta, of the reciprocal of the sine of theta, I'm sorry. The quickest way to draw it is to draw the sine, okay, just with the dashed lines, okay? So here is 1, that should be 1, that should be 0, that should be negative 1, and that should be 0. So I'm going to do this, the same shape I did here. The cosecant goes to negative infinity. It goes to, I'm sorry, goes to positive infinity here. At 1 here, because 1 divided by 1 is 1, and then to infinity again here. So this would be an asymptote like that, and this would be an asymptote. I had to add the graphing here because next time we'll do shifted graph. Okay, so the cosecant starts at positive infinity at 0, goes down touches the sign at 90, which is 1, because 1 divided by 1 is 1. 1 divided by 1/2 is 2. 1 divided by 1/3 is 3. 1 divided by 0.000001 approaches infinity. So you get this U shape here. And then it goes down to negative infinity, touches that here, and then goes back asymptote with negative infinity. And then it starts to repeat again. Here it's the exact opposite. Again, the easiest way to plot it is to draw the cosine curve. I'm going to draw it. Here it's 1, 0, -1, 0, 1. So it's looking like that. You can draw it with a pencil and then erase it at the end. Okay, so my graph starts at +1. And then goes asymptote with this. And then it comes from negative infinity to 1. And then asymptote with that. And then comes asymptote with this line, touches at 1, and then it will go back. And then I erase this. So that's the shape of the secant. We didn't write that, secant theta. If I want cotan theta, so this is tan. Cotan is 1 over that. Okay? So when the tan at -90, when the tan is at negative infinity, that is at 0, because 1 divided by that is 0. When it's at 1, at -1, I'm sorry, that also would be at -1. And then when this is at 0, but slightly to the left, it's slightly below the 0. So it's negative, so that would be negative infinity. At the right of 0, this is a very small positive value, so that would be positive infinity. And then here, at 1, it will be 1 again. And then this is 0. Oh, I'm sorry. Why? This is 1. I'm sorry. This is 1, and this is 0. And then again, it will go to -1, and then negative infinity here. So the graph looks something like that. So, and then this again comes from here to the 1, and then goes to -1, and then negative infinity. And it will keep repeating. Wherever here is 0, that would be asymptote. Wherever this is an asymptote, that becomes a 0, because it's the opposite. And these are the 6 graphs cotan of theta. I will stop here, and that leaves us with only one more session. Again, if you have any questions, please don't hesitate to email me or leave a note. I will get back to you as soon as I can. And otherwise, I wish you all the best. We are almost there. We finished the course. So after that, I want you to try some of the back exams. I have them with the solution. So try it on your own and then check your answers. And again, thank you very much for watching. Have a great day. Bye.